Let us talk about trigonometric identities. Trigonometric identities. Now we know that the equations which are true for every value of the variable involved, true for every value of the variable involved, are known as identities. And now we are talking about trigonometric identities. So we will talk about equations which involve trig ratios and are true for every angle that is involved, right? So for example, in the previous lectures we discussed about sine square theta plus cos square theta equals 1, right? This is one of the identities that I am going to discuss here, right? Now theta is an angle that we are talking about. In class 10th, if you are preparing for only the CBSE board, then you will be concerned with acute angles, right? But now these lectures are for IIT foundation, so that to create a strong foundation for your IIT preparation. So I'll take that discussion beyond class 10th also, but you should be very comfortable with this the lectures that I'm going to give you, and you are supposed to do these lectures if you are preparing for IIT, right? So sine square theta plus cos square theta equal to 1 we discussed. Now in class 10th you will be getting acute angles, right? But we will understand in some upcoming lectures that this identity is true for even bigger angles, right? So it is true at every value of theta. It is true for every value of theta. Now we may have some identities which are not true at some of the values, so we will exclude those values while writing that identity, right? So let us discuss how did we arrive at sine square theta plus cos square theta equal to 1. In brief, once again, let us say we have got a right triangle here and this angle be theta. If this side here is, let us say, small a, this side is small b, and this side here is small c, right? Then we know sine theta is opposite by hypotenuse, that is a upon c, and we also know that cos theta is equal to adjacent, that is b upon hypotenuse, that is c. So we know sine theta for this triangle will be a upon c and cos theta for this triangle will be b upon c, right? Now if I square and add these, then sine square theta plus cos square theta will be equal to a square by c square plus b squared by c squared, which is equal to a squared plus b squared divided by c square. Now this is a right angle triangle, right? So we can apply Pythagoras theorem in this triangle. What is Pythagoras theorem? What does it say? That hypotenuse square, that is c squared, is equal to the altitude squared plus base squared, right? So this is what Pythagoras theorem says. Pythagoras theorem, right? So now a square plus b square is nothing but c squared. So what I can do here is I can replace this a square plus b square by c square, right? So sine square theta plus cos square theta, so it will be c squared by c squared equal to 1. So sine square theta plus cos square theta is equal to 1, right? We also discussed in previous lectures that then sine square theta can be easily written as 1 minus cos square theta, right? Cos square theta can be written as 1 minus sine square theta. Okay, now the trick is not to learn sine square theta plus cos square theta equal to 1. We should also know that 1 can be replaced with sine square theta plus cos square theta. Okay, in some of the manipulations while solving questions, we may have to replace 1 with certain identity. So it will depend on our immediate IQ, right? Instant IQ, that we can replace 1 with sine square theta plus cos square theta if required. So you have to learn these identities from left to right as well as from right to left. Okay, and use these identities as per your requirement. So sine square theta can be written as 1 minus cos square theta. Similarly, cos square theta can be written as 1 minus sine square theta. Now in some of the books it is written that sine theta is equal to root of 1 minus cos square theta, but it may not be always true, and it is not always true, because in class 10th it might be written in some books, because we are always talking about acute angles, right, where sine theta, cos theta, these have got positive values, right, because we know that if you write something like this root 4, then it means 2, right, it is positive value. Or if you have written something here and you are getting a value here, it has to be a non-negative value, it cannot be a negative value, right. Square root of something cannot be a negative value, because we are talking about principal square root here. The correct expression for this would have been if you had written plus minus here, but for acute angles you can simply write this: sine theta is equal to square root of 1 minus cos square theta, then it will be all good. Now another thing, that if sine square theta plus cos square theta is equal to 1, we can have we can find other identities by a little manipulation in this identity. If I divide both sides by sine square theta, let us say, then what will happen is this will be sine square theta by sine square theta, and this will be sine cos square theta by sine square theta, and here I'll have 1 by sine square theta, right. Now this will become 1, this is cot square theta, and this is nothing but cosecant square theta, right. So this gives me another identity, that is cosecant square theta minus cot square theta equal to 1. Again I'll ask that question, is this true for every value of theta? Because if to be an identity, it has to be true at every value of the variable, in this case at every value of theta. But when you're talking about, let us say, even this identity is not even true for 0 and 90, right. What happens is cosecant square theta is nothing but 1 by sine square theta. So sine 0 is 0, so this will become 1 by 0, which is not defined, right. I hope you understand this, the what I'm trying to say here is, right. And cot square theta is cos square theta by sine square theta, again at 0 degrees this will become not defined. So cosecant and cot both are not defined at 0, so this identity is not always true, right. We have to exclude those values where the denominator is 0. So while we are in class 10th, we can write that this is true for values greater than 0, if theta is greater than 0, and less than or equal to 90 degrees, right. Rest of the values are okay. Between 0 and 90, all values are okay. All right, I hope you have understood this identity, which we got by dividing the first identity, that is sine square theta plus cos square theta by sine square theta. We divided it by sine square theta. Now let us divide this identity by cos square theta and see what do we get. So the first term will become sine square theta by cos square theta, this will become cos square theta by cos square theta, and this will become like this. So what do we have got here? Here I'll have tan square theta, this will become 1, and on the right hand side I've got secant square theta. So the identity that I get is secant square theta minus tan square theta is equal to 1. Okay, so we have got three identities: sine square theta plus cos square theta equal to 1, then this secant square theta minus tan square theta equal to 1, and cosecant square theta minus cot square theta equal to 1. Now that we are talking about theta being between 90 and 0, we also saw that this identity was true for all values from 0 to 90, as well as 0 and 90 also. but this identity here was true for all values between 0 and 90, but was not valid at 0, right? So I have not written equality here, okay, but at 90 it is okay. So I put this equal sign also. Let us talk about secant square theta minus tan square theta. So this identity also will not be valid for the values of theta at which the denominator is 0. So what is the denominator in this? Secant square theta means 1 by cos square theta. Tan square theta means sin square theta by cos square theta. So the values of theta where cos square theta is 0, this identity will not be valid. So cos theta, cos 90 is equal to 0, right? So this identity will not be true at theta equal to 90 degrees. So we will write this as this. Theta should be less than 90 degrees, greater than or equal to 0, right? So this identity is true for all values of theta greater than equal to 0 but less than 90 degrees, right? In your class 10th, we will talk about these angles only. But I will teach you about the higher angles also. So in these two identities, secant square theta minus tan square theta equal to 1, cosecant square theta minus cot square theta equal to 1. We can do further manipulations like this. So this is a square minus b square. So I can write secant theta minus tan theta into secant theta plus tan theta and put it equal to 1. So it is equal to 1 and this is product of two things. So these two expressions are reciprocals of each other, right? So secant theta minus tan theta can always be written as 1 by secant theta plus tan theta. When I say can always be written as, I mean at those values of theta at which this is valid, right? This identity should be valid first of all. So we will always exclude those values where the denominator becomes 0. And similarly in this case, cosecant theta minus cot theta is equal to 1 by cosecant theta plus cot theta. Now these are very simple expressions, but when you are doing the questions, this should strike in your mind immediately, right? These identities, you can learn this, that cosecant square theta minus cot square theta equal to 1. But when it comes to the questions, you should know when to replace 1 with this expression here on the left hand side. You should know if cosecant theta minus cot theta is given as equal to something, then you can immediately know the value of cosecant theta plus cot theta. For example, if I give you, let me select a question first of all. If I give you secant theta plus tan theta is equal to 1.5, let us say, and I want you to find sin theta, tan theta and secant theta, let us say. This is what you need to find, and I have given you secant theta plus tan theta equal to 1.5. Now just by looking at this, secant theta plus tan theta equal to 1.5, this should immediately strike in your mind that secant theta minus tan theta being the reciprocal of secant theta plus tan theta will be equal to what? This is 1.5, that means it is 3 by 2, right? So secant theta minus tan theta is nothing but 2 by 3. This much this much should strike in your mind immediately, so that you can do the questions very fast. Now you can solve these two equations. By adding these two equations, I can cancel this tan theta, and twice of secant theta will be equal to 3 by 2 plus 2 by 3, right? Which is nothing but 13 by 6. Hence, I can say secant theta is equal to 13 by 12. I have brought this 2 on the right hand side. So now that I have got secant value of secant theta, I need to find sin theta and tan theta. Secant theta I have already found, okay? So let me find all the other trig ratios for you. Now secant theta is 13 by 12. If it makes your life simple, then you can write cos theta is equal to 12 by 3, which is just the reciprocal of secant theta. Now if you notice, you can make a triangle here, right? And consider any of these acute angles as theta. Let us say I consider this angle as theta. Now you know cos is adjacent upon hypotenuse, right? That means if this ratio is given 12 by 13, I can always consider this adjacent side as 12, but if I consider is at 12, then hypotenuse I have to take as 13. Or this is a ratio, right? You should appreciate it. You can always take it as 12x, then you have to take it as 13x. But to make it simple, let me take it 12 and take it, I'll have to take it 13 then to maintain this ratio, right? Once you have got these two sides, you can always find the third side by applying Pythagoras theorem. And some of you may know that 12, if one side is, if one of the sides is 12 and the hypotenuse is 13, then the third side will be 5, because 5, 12 and 13 are also known as Pythagorean triplets. Pythagorean triplets. If somebody is not comfortable with this idea of finding it directly, he or she can always apply the Pythagoras theorem and write this side as 13 squared minus 12 squared square root. This is 169, this is 144, and the difference is 25, so you can write it as 5 units. Now that I've got this triangle with this angle theta here, how simple is it to find sine theta? It is very simple, right? Sine theta is nothing but opposite upon hypotenuse, that is 5 by 13, right? What is tan theta? Tan theta is opposite by adjacent. Opposite is 5, adjacent is 12, so tan theta is 5 upon 12, right? Cos theta I have already found. Rest of the angles you can find, like cot theta is just the reciprocal of 5 by 12, that is 12 by 5, and cosecant theta is 13 by 5, right? So you should know these manipulations. And even in higher classes, when you get the, let us say, questions involving logarithms, let us say you get ln secant theta minus tan theta as the answer of some of your question, but in the options given, let us say you solve a question and you arrive at this answer, okay, but in the answer options you see this expression is not given, but there is an expression minus ln secant theta plus tan theta. Then it should immediately strike in your mind that by the property of log, this negative sign is taken outside. In fact, it is 1 by secant theta plus tan theta. Or I think we will practice it more, then you will come to know that these two expressions are same. Just because secant theta minus tan theta is the reciprocal of secant theta plus tan theta. That's why this expression can be written as this expression also. So this will go a long way. Trigonometry is a foundation tool for other topics also. So you should be really comfortable with these ideas. All right, let me take one more question before I finish this lecture. Let us say this is given, okay, and we need to show that this expression here is equal to plus minus 3. Now let us first of all take what is given, 3 sin theta plus 5 cos theta is equal to 5, and let us consider this expression on the left hand side as equal to x. 5 sin theta minus 3 cos theta is equal to x, let us say. Okay, now I have got sine theta cos theta, then it should strike in my mind that somewhere I can use sine square theta plus cos square theta equal to 1 while solving these equations. So let me squaring these equations. What do I get? By squaring this first equation, I'll have 9 sine square theta plus 25 cos square theta plus 2 into 3 into 5, that is 30 sine theta cos theta, and it is equal to 25. Now squaring this one, 25 sine square theta plus 9 cos square theta minus 30 sine theta cos theta. Now you notice that it is very easy to solve these two equations, because if I add these two equations, these terms can be cancelled. So let me add these. So if I add this first term with this term, I can take sine square theta as common. 25 plus 9 will become 34. Plus, similarly, I can take cos square theta outside. 25 plus 9 will again be 34. And these terms have already been cancelled, and on the right hand side, I'll have 25 plus x squared. Now see, I can again take 35 common, and inside I'll have sine square theta plus cos square theta, which is a known expression to us, right? This is equal to 1. So 34 is equal to 25 plus x squared. 34 minus 25 is 9. So x squared is equal to 9. So I can say that x is equal to plus minus 3. X is equal to plus minus 3. And what was x? This expression here, I had considered this as x. So I have proved that x is equal to plus minus 3, which means this expression is equal to plus minus 3. Hence it is proved. So this was about these basic identities. Okay.